Hi, welcome back to the Introstat lecturing series, Testing Hypothesis Unit. This is the video number 3 on the lecture number 8, hypothesis testing for the two population means. So in this video, we're going to take a look at two examples, and I'm going to show you how to use the calculator and how to use the R to get the values here. Okay, and from the previous two videos, first video, we talk about what is the z-test, when we use z-test, and then the second video, we talk about is when to use t-test here. So let's take a look at some examples from the how to do the testing for the two population means here. Okay, let's go continue to our lecture notes here. Okay, so here, this is what we did, right? So the t-test, we have a pool, not a pool, those things. Okay, so let's take a look at this ones here. All right, so for this problem here, let's take a look at what the problem wants us to find. So let's say, suppose you want to compare new method of teaching reading to a slower learner to the current standard method. You decided to base this comparison on the result of a reading test given at the end of the learning period of the 6 months. So of a random sample, 20 slow learners, 8 of them were taught by the qualified instructor under the similar condition for 6 months. Okay, so the test result of the reading test at the end of this period are summarized. Does this data provide enough evidence that that the new methods here is more efficient? That means it's better testing scores here. Okay, so here is the information they give us. This is a new method and this is the standard methods here. Obviously, this one's here, right? So this is sigma 1 and the sigma 2 is not given, right? So this is not given. So if this is not given, so I know this will be what we're going to use the t-test here. Okay. Okay, so now let's try to put out what is our hypothesis testing. So the hypothesis testing, we said non-hypothesis is new, so it's equal to the standard, to the mu, to the standard, right? So this one is equal to the mu to the standard. Or, to simplify it, maybe it's better. Let's just write down the mu1, mu2 here, all right? So maybe that's easier. So mu1 equal to mu2. So the new standard, let's put a note here is mu1. Standard, this one, new method is a new one. This is mu2. Okay, so I want to see the new method is more efficient, right? So this is mu1 is what? It's greater than mu2, correct? All right, so that's good. So it's mu1 is greater than mu2 here. And then let's see which tail we are looking for. And because it's mu1 is greater than mu2, then I'm looking for this tails, right? Okay, so it's right tails, okay? So now let's take a look in here. We said test the statistic because Z sigma 1, sigma 2 is not given. So what test we use? We use the t-test here. Okay, so those are the given value. So of course you can plug into the formula, or let's take a look at how do we use the technology try to help us here. Okay, so now let me go to the TI-84 calculator and then I show you how do we do that. Okay, so make sure you follow the right. See here, so you do stat. Remember we talked before, you do test. And now for the test, this is what? This is a two sample t-test. All right. Okay, so you enter. So you have a summary statistics here, right? Okay, so hit enter, go to statistics. So the first one is X1 bar. So from our problem from our example, what is that? Is 76.9. Okay, so also they tell you the standard deviation for the new method is 4.85. So you say 4.85. Then what is the sample size? You have 8 students, right? Okay, so X2 here is the standard method. So what is the X bar? Is 72.7. And what is the standard deviation? Is 6.35. And what is the sample size? Is 12. Okay, then you push this button to going down. So what we are testing, mu1 greater than mu2. So you say mu1 greater than mu2. So you do here. Okay, continue going down. Say, do we want to pool or not pool? Like I say, I always like to be pooled. So you say it's yes. And then you say calculator here. Okay, so after you hit the calculator here, and now you can see here, this is what? This is your t value, right? So 1.583. And what is this number here? This is the P is 0.6 of 0.0654. And take a look here, because I use the pool, right? Because I use the pool, my degrees freedom is 18, right? So how do I get my degrees freedom? Is N1 is A plus 12 minus 2. That's why you get 18. If you use not pool, then your degrees freedom will have some decimal, all right? Then the most of the t-table, you cannot find a critical value with a decimal degrees of the freedoms here, okay? So this is how do we use the TI-84 calculator. It's pretty straightforward, right? So now let's go back to our let's go back to our lecture notes. So what do we find here? So the t value is 1.583. Since they give us the p value, so the p value is equal to what? 0.0654. And did they tell us what the significance level? No. So if it's no, we assume it's 5%, right? If they did not tell us, then I assume the alpha is 0.05. So this value is greater than 0.05. So what is our conclusion here? Our conclusion is fail to reject H0, right? So what means fail to reject H0? That means the new method, the data does not provide significant evidence to support that a new method is more efficient, right? So that's what the fail to reject means. That means the data does not provide significant evidence to support new method is more efficient than the standard methods here. Okay, all right. So now let's take a look how do I do by using R here. Okay, so let's take a look at the R here. So where is my R here? All right. Okay, so in order to get an R here, right? So the first things, okay, you need to do the pool, right? So that's you type in, you said S pool, POOLED. Okay, so the pool you say is equal to Okay, so you said the S pool is equal to the square root SQRT. Okay, and then you put a parenthesis, and then in here, so in here you put the first sample size is 8, so you put a 7 times, like 4.85, and that is the S1, then you need to square that, right? So it's a 4.81 square, then plus the second one, how many sample size you have? 12. So 12 minus 1 is 11. So it's 11, right? Times what? 6.35, then square here, right? Okay, now, okay, then you divide by, okay, so you divide by what here? You divide by 8 plus 12 minus 2. Okay, so this is your the pool standard deviation. So here, let me, so okay, so in here, after you hit that, S pooled, it will give you what is the S pool, POOLED will give you 5 point, so the 5.81. Okay, so now you can say XPT. All right, so XPT, then you do, so you put your 76.9, okay, minus 72.7. That's your X1, X2s, right? Okay, and then you divide by S pool, right? So you say SPOOLED. So you say S pool, then you need to times the SQRT, right? So you times the square roots, then it's 1/8. Okay, so you times the square roots 1/8 plus 1/12, right? So be very careful about all this 1/12. Okay, then you will set degrees freedom equal to 18, right? Because I know is that. And then you can say the lower tail equal false, because it's greater, so I want to the up tail. I hope I typed it right. Let's see here. Okay, so I must did something wrong. See here, okay, XPT. So let's see here. So XPT, which one I did wrong? Type the A is not find. Okay, so let's see here. So it's the XPT 76.9 minus 72.7. Then S pool, SPOOLED times the square SQRT, and then the square roots 1/8. Here is 1/12. Okay. Boom. Okay, so good. Okay, so now, like we said, the nice of the R is always will give you some nice, beautiful graphs, right? And because this is one tail test, and so it's a tail, so this is your what? This is your p-values here, right? So it's a pointer. As you can see here, it's a 0.065. So it's exactly the same as you got, you got it from the TI-84s here, right? So the key things here is these two, right? Okay, so make sure you input, right? So you type in the pool. So how do you get a pool? And then you use XPT. That means you graph the T distributions, okay? And then you will get it. Okay, all right. So that is a pretty cool here. They will give you the same answer here, okay? Now let's go back to our lecture notes, and let's take a look at our next examples here. Okay, so now this example here, okay, so let's try to do it one more time to see we'll be able to reproduce the result by the calculator and by the R's here. So we say experiment has conducted the university to compare the mean number of study hour expended per week by student athletics with mean number of hour expended by the non-athletics here. So a random sample of the 55 athlete, okay, so the 55 and will produce a mean equal to 20.6 hours study per week, and the standard deviation was 5.3. Then the next one's here. So a random sample of 200 non-athletic students and produce 23.5, and the standard deviation is 4.1. Okay, so that's why I color code that so you can see. So they want to see, do the sample provide sufficient evidence that there is a difference between these two groups, right? So if there is a differences in the mean number of the study hour between these two groups. All right, so let's see here. So this is the, we say it's a mu1 is equal to mu2, correct? And then they want to test its differences. So I said mu1 is not equal to mu2 here, right? So of course the mu1 is, this is what? Mu1, this is selected student, and the mu2 is non-athletic. Non-athletic students, okay? So because sigma 1, sigma 2 is given or given, not given? It's not given, right? Okay, so that's why, what type of test I need to use? I need to use a t-test here. Okay, okay, so now let's try to use the TI-84 calculator again one more time here. Let's see what the answer we will produce here, right? So here, okay, go ahead, let's start, clear this out. So you will do stat. Okay, so the test here, right? So now what test we do? The two sample t-test. We wanted the statistics. Okay, so the first group is the, what is the mean here? Is 20.6, right? Okay, so it's 20.6. And what is the standard deviation? 5.3. Okay. What is the sample size? 55. That's why I color coded when I read the problem, so I won't mix up, right? So if you color code, that will be easier to see. Okay, now the X2 will be non-athletic. So this is 23.5. And standard deviation is what? It's 4.1. And what is the sample size here? Is 200 here, right? Okay, so what we are testing? We are testing is not equal to, all right? So you need to choose this one. So remember, we always choose yes. So we want to pull, right? So you choose yes, and then you do a calculator. Okay, so now you will get this one's here. Okay, so in here, you will see this is your t-test. It's negative 4.344. And your p-value is here. Is remember, don't forget to read this one, right? So this is 2.0194 to the e, e to the negative 5. That means you write this is a 0.00002019, right? Because e to the negative 5, what's that mean? That means you are moving 5 decimal points. 1, 2, 3, 4, 5, right? So it's 2.0194. 0.019. So it's 0.00002019 here. Okay. All right. So let's go back to our lecture notes here. And so we know the t-test. So what do we have as the t-value? So the t-value here we got is a negative 4.34485. And the p-values here is 2.019 for e to the negative 5. That means this is 0.00002019. This is way less than 0.01. So what is the less than 0.01 mean? That means I'm rejecting what? Rejecting the non-hypothesis, right? So that means I prefer the HA. So how do we say it? So we'll say, data provide sufficient evidence that the study hours between these two groups, they are different. All right. Okay, so now let's take a look. How do I use the R? Try to do this. Okay, so let's take a look. This is the what we did a while ago. Okay, so now first things here, right? So I'm still need to looking for the S pool. So let me copy this one down. Okay, so now the S pool, the first, you just need to change the number, right? So the first ones here is 55. So -1 is 54. So what is the standard deviations layer? So 55 was the standard deviation is 5.3, right? Okay, so I need to change this number to 5.3. Okay, so then plus these numbers here. So I have a 200s. So -1 is 199. And what is the standard deviations for the 200s is 4.1. So you just need to change this to the 4.1. So if here, if you get one down, you can just copy that. And now what is here? You have a 55 plus what? Plus 200s, right? And the -2. Okay, so far so good. Okay, so boom. So you got your S pool. Okay, so now after you get your S pools here, and now you can just copy this XPT here. Okay, so you can copy down here. Okay, so paste here. Okay, so now you just replace the different number. So the first group, this is 20.6 hours, so it's 20.6 minus what is here, 23.5. So 23.5. Okay, then you use the pool times 1 over what? 1 over 55 and 1 over what? 1 over 200s, right? So 1 over 200s. Then the degrees freedom, we know is 255 minus 2. So degrees freedom, what is degrees freedom? Is 253. And you want to do the lower tail or up tail, doesn't matter. So let's try, say the lower tail is true. See, let's see what you get here. Okay, let's see here. All right, so the boom. Okay, so here, because the here is so small, right? So you barely see, but then here you can see the results here. They give you the tail value, right? So this tail value is 1.0097 and the e to the negative 0.05. Then you say, hey, this is different than the TI-84. Correct. This is different. The reason why it's different because they give you, so this is the one tails here they give you. It's very, very small, right? So it's now because our hypothesis is a two-tail test. So remember that. So what is our p-values here? P-value will just be the 2 times 1.0097 e to the -5. So it will give you the similar number. So we'll give you 2.0 what 19 to the e to the -5. So we'll give you the same p-values, right? So remember the p-values here, right? If it's a two-tail, you need to times 2. And if you use the TI-84 calculator, you don't have to because it's already programmed in there. Okay, so that's the only thing you need to remember when you use R's here. Okay, let's see it. So that is for this lecture, how do you test the two population means here? So remember the few things, right? The sigma 2 is given, you use a z-test. If sigma 1, sigma 2 is not given, you use a t-test. So if you use a TI-84 calculator, you will get the p-value right out from the calculator. If you use R, the things you need to be careful is, if it's a two-tail test, then make sure you times your tail area by 2. Okay. All right, that's it. Okay, so now we finished the testing hypothesis for the two population means here. And now we're going to talk about our last hypothesis testing, is we call it the pair test. Okay, all right, so have a good day and talk to you later for our next test here. Okay, bye, have a good day.